around my arms. Don't let's cry now. Dance with me. Stop your tearing up. Don't you hear the music? Don't you feel the happy beat? Bring your paddle, dance with me. We will dance to our own song and whirl around. All you children gather round. We will dance together. We will dance together.
Session. 1 2 2 1. Mic check. Check check. Check check. Check. Check check. Check. Check check. Check. All right, I'll request the guys to come back for the session. The guys on the other side, please come back. If you are not finished your food, come with your food. Quickly, quickly, so that you're not left out. I'm going to share something very interesting here that you should not miss. Guys on the other side, please come back. Come with your food. Every minute counts going forward, so that, you know. Yeah. Are you okay with the food? Do you want some more? Yeah. Today we'll make sure even you go home when you're full. So don't make plans. It's Saturday. Enough food even for evening. Isn't it? So relax. Relax. Just make sure your profile is working. You don't doze off. And you're focused. That's all. All right. So quickly, I want to take you through Africa stocking. There's something that maybe some of you have not noticed. All right. So if you go to africastocking.com, you'll find this. I don't know. Yeah, you'll find these tabs here. So each tab you click gives you some drop down. And the first one is all the products. And some of them are in testing, so they might not appear here, but they are on the documentation for the devs. Then there's pricing. Pricing is clickable, and you can get all the pricing for different countries. And some of them you can get an option to request for the service. Then we have platform. This is where I'm focusing more. So there are two platforms here that you should pay attention to. But the one that is most important for you is the first one, marketplace. The other one, unless you want to do low code, no code, also you can feel free to check it out. You can set up USSD without much of coding and all that. But you're devs anyway, so that should not be so interesting. Marketplace is where I wanted us. Allow me to open. And yeah, then there is, of course, about us. If you want to know about us, our story, how the company started, the values we stand for, this is your place. Then there is, of course, FAQ. There are some questions that you may ask, but already someone else has already asked in the last 15 years. You can go and check them out, all right? So, talking of marketplace, two things that you need to note. Number one is that you can actually publish your capstone project once it's ready. You just need to create a Docker image, submit it, and it will be reviewed. If it meets all the criteria and it's safe, it's going to be published. Now, what does that do? It exposes you to our customers and our community so that they can consume what you build. All right? However, between now and the first quarter of 2026, we might not be as tenacious, and the turnaround time might not be the AT standard turnaround time. But we'll definitely review and give you feedback if your app is ready, if it's marketplace ready. So this is marketplace 2.0. But something you can consume as of next moment, if you wanted, is callback as a service. I know most of you, when you're building projects, you normally consume ngrok, right? But at scale, we are providing you with callback as a service, which can host your callback, isn't it? So you guys are already familiar with callback. So you can actually consume that through the marketplace. It's an app that is already there. So as you can see, that's why it just took you to there. Maybe I should have a test account where I can show people how this works without them seeing my dashboard. Yeah, so this is just admin dashboard. It should not scare you. These are some of the test apps that have been created to test the capability. Then, of course, there's transaction and billing. You can see your bills here. Then there is a plan. You should be able to see the callback as a service, all right? The charges are quite fair. They're charged per transaction. So if you make a transaction and it's as well as Docker this with you, look more confused like Yes, but humans study through activities, through interaction, through experiences, through trauma, through different engagement, through happy moment, through sad moment. So over time, they can actually enhance their natural intelligence. Some of you are looking at me surprised. Is that simple? Is there another mic?
A period of 1 month.
Yes.
So what is the cost for that? Then secondly, there are like a free option for the plugins for Africa stocking that someone can use as a developer.
Yes, so the sandbox is always free. So if you are testing a solution and it's not live, you can actually test the sandbox. And the difference between sandbox and live is just you changing your API key and maybe even username if you don't want to use the testing account. But definitely once you change your username, if you just still want to use the app name or username, once you change the API key, it can actually go live. Now, second thing is that, of course, once you sign up and as a first timer, you get 10 shillings. That 10 shillings, you can actually test. How many messages are there in 10 shillings? Like 10, 15, 20? Yes?
Hello.
Pop up. Discussed earlier.
Oh, yeah. Okay, I'm manifesting.
It is there,
a
it's just that,
laptop. Okay.
but it's there. It's about time, man. You come and greet the people of Mombasa. Graham is one guy who loves Mombasa a lot. So begin my coffee as he comes. So you see how I've gotten to my account, right?
Yes.
Yes, hi everyone.
Hi.
How are you doing?
Very good.
Are you enjoying the experience?
Very much.
Yes, so yes, as MK said, I love Mombasa. It's my home, I think. I need to find a way of making it my home. So, yeah, we're very happy to be here. I must apologize, we have not come here for a very long time. Hopefully, we will start being here. We are looking to do a monthly event with you guys here. So you can expect the same energy, the same experience. And yeah, so most important is just to make sure you guys are learning. We have a lot of interesting speakers or things we can do together, but we are technical guys, so you can expect it's always going to be around hackathons, workshops, and once in a while some fireside chats. But we are not very big on fireside chats. We are big on coding and learning. So yeah, we are very happy to be here. I think they're going to, MK and Douglas are going to show you the callback as a service. That means if you're building an app and you don't need to use local host, you can put your app in, you can push your app to GitHub. You can trigger your GitHub actions. We receive them on our side. We run your app. We give you a URL, which is a callback. The same callback that ngrok gives you. How many of you have used ngrok today? Or you call it ngrok or ngrok? Yeah, how many have you? Okay, ngrok. Yeah, so we ideally can help you with that. So that means that we also give you 10,000 free events every month. Every month, Kaka? Yeah, I think so. Which is enough for you to build in a real cloud environment. So, it's a real cloud environment. You get HTTPS. And when you are ready to go to production, maybe you are building it for a customer, then of course the customer will pay, so you don't need to worry. Customer will pay for their cloud. Another thing I was surprised, you guys don't use GCP. How many of you use GCP? How many of you have heard of GCP? 1, 2, 3. GCP? AWS? So these GCP people, they never show up here. Yeah. Okay, GCP is Google Cloud. GCP is Google Cloud Platform. But then, if you don't know GCP, you still don't use it well. Because no one calls it Google Cloud Platform. If you are using it, it's called GCP. Anyway, guys, See you around, but I'm very excited to be here. Thank you very much.
Thank you so much, Graham. Yeah, what's your name? Yeah, you saw how I came about this, right? Can see I have some money, so always get your wallet and under billing, can always top up, right? So there are different ways to top up depending on where you are. And one of the favorite developer top up in different ecosystem where M-Pesa is always M-Pesa. Yeah, but in other countries, it will give you different options, and you can top up. Yeah. Did you get how I navigated up to this point?
Yes, I got you.
So where did I go?
You went to the account, and then you pressed on an app you're already building.
Yes.
So that you can pull up the dashboard and stuff.
Yes.
Thank you. So I also have another question. This is going forward to Google people and M-Pesa Express. Why is it unavailable in most of the Android phones like mine?
What is unavailable?
M-Pesa Express.
What is that?
Ile ya checkout, you want to pay for a subscription, Google. I do not have a debit card or a credit card, but I should have this subscription.
Yeah.
Now they're telling me to put M-Pesa Express, but then it is not available for my type of phone. So what's up? Is that discrimination or what?
Yeah, we'll take this feedback to Google people, but you might be running an obsolete OS. You know, some of those.
Spark 20 is obsolete.
Which OS are you running for Android?
Spark 20.
That is the latest.
I don't know.
Is it cracked?
I have no idea.
Now, you need to know that because sometime when they stop supporting the OEM, then it becomes sometime, even the developers of certain apps don't include it in their version. Because also remember, M-Pesa gets updates all the time.
Okay.
And some of these considerations are some of the things that they update.
Okay.
So once they update and your phone is not supported, you don't get to access it.
Okay, no problem.
Yeah, there's so much in that, beyond Google and just M-Pesa. Yeah.
Okay, thank you. I think I'm now satisfied. We can go on.
Yeah. Okay.
Yes.
All right. Yes. Mainya, you can be sharing your screen so that we start, if you can hear us.
Thanks.
Yes.
But how can we access the stuff if we don't have the SIM card in the laptop?
Which stuff?
The 10 bob. If we don't have it in the laptop, and if we don't even have the SIM in the laptop, how can we access it?
No, that's already the credit that you have. So most of the time, all these applications. Oh, guys, Mohammed, for those who are joining us online, you can hear the voice only. I don't know if my camera people, you are showing who is Ahmed. He's like 10-year-old kid who is learning the ropes. And he is asking some serious questions more than some, Yeah. Some dude who are in the university, some of you have graduated, be curious, guys, be curious, be challenged. But just to answer you, Mohammed, so some of these applications, they use modern technology whereby if you want to pay for something and you input your number, they use the network to ping your number to be able to pay, all right, where you're using your mobile number. However, the 10 bob you're talking about is already preloaded credit from Africa is talking. The same way you would load credit and you'll see it there. You have seen I have like 210 shillings, right? So if I had the 10 shillings and I loaded 200, then you'll see it. I have 210 in credits. So that credit today, before you could only use it for specific solution. But your credit, you can use it for virtually anything. You can use it for voice, you can use it for SMS, you can use it for USSD, you can use it for airtime, you can use it for mobile data, and so on and so forth. All right? Chat API, Insight API. All right? Does that make sense? So you don't need a SIM on your. In fact, SIM cards are becoming obsolete. Maybe in 5 years you don't need a SIM card.
So what if we put a different number in the laptop and that guy's a millionaire?
You add more credit that you need.
I'm saying, what if we put someone else's number?
Yeah, so there are different verification method, right? So for instance, if I put Mohammed number and I want to pay for my account, until you enter your PIN, I might not be able to pay, all right? Are we together?
So what if the pin is 1, 2, 3, 4?
Now you should not have a 1, 2, 3, 4 PIN. Is your PIN 1, 2, 3, 4? Yeah, you should not have such a PIN, but nevertheless, you have to add that PIN on your side. Make sense? Yeah, yeah. Any other question, Mohammed, before you go on?
No.
You're good?
Yeah.
All right. All right. Thank you so much. What were you fixing on that laptop? I saw you fixing something on the laptop next to you.
I was just showing him my website.
Oh, not the PIN. Okay. All right. All right. So thank you so much. I think Ben is ready to go. So let me just increase the screen. So don't mind this sidebar. Can you see everything? Yes, no? Not sure. Is that better? Is that better? I think the engineers at the back are engineering in real time. Eh? All right, so before I go, Ben Mainye is our data scientist and also more or less machine learning AI engineer. So he's gonna take you through this session, which was the main session, module 6 to 10. And one of the key things is that if you have any question, feel free to come and ask. I don't know, should they come and ask with this mic or you'll give them another mic? If someone has a question, should someone come in front and ask using this mic? Yes, no? If someone has a question in the room, for Mainye to hear them, should they use this mic? This mic. All right, thank you so much. So Mainye, the floor is all yours. I'm just switching this mic in the meantime.
Okay, can you guys hear me okay? Maybe a thumbs up would be appreciated, like in the chat, if you can hear me. Okay, great. So also for Bevy, or this platform, like where I'm talking, I think there's a small icon there with above the B of my account for Google here, where you can just expand the screen so that you can see it in full screen. Okay. Okay, great. So the part where what I'm going to be talking about today is mostly hinged on statistical modeling. I will tell you what that is. But before we move into the actual content, I'd want to just take a small detour to give you some introductions to some important things, just in case this is your first time hearing them. So okay. So the first thing is this whole paradigm that we use in machine learning. And let me take another step back about machine learning. So the classic story here is when you're trying to figure out if it's going to rain the next day, you normally you're normally more observant about the previous days. Like, did it rain like on Monday, Tuesday, and then let's say it's Wednesday, and then you try and say, hey, since it rained on Monday and Tuesday, then it's probably going to rain on Wednesday. So you carry your raincoat or umbrella when you're doing your daily activities. So that's just the classic way of how human beings make decisions. And in machine learning, it's a bit different because this time you're giving the computer data about the same information that I just mentioned, about if it rained the previous day and other influencing factors that can lead to rainfall. Then when this data is gotten by this algorithm, for instance, like let's say that is able to maybe summarize that whole relationship between the different aspects of weather, you're able to say, hey, it's going to rain on Wednesday. So that's just a classic way of what happens in machine learning. It's just the computer making decisions based on the data from the past. So those are the definitions I'm going to that I've cleared so far. There are going to be more. I just don't want to assume that everyone in the room knows what these things mean. So there's a diagram over here of the classical route that goes on when it comes to software engineering. And usually, let's say you're coming up with maybe a page to sign up users for your service. Like, you usually have some logic that you have, like if certain steps are taken, like if information is typed in, and like for instance, maybe the person's email and password as an example, this is then maybe stored in a database. And obviously, I'm making this example like very, very simple, no like interesting authentication things that happen in between. But from that explanation, you can acknowledge that, let's say you can acknowledge that the whole process has been solved, at least for the first part. And then the second part is the one that I've told you about, the weather problem, predicting whether it's going to rain the next day, where you give data from the past, and the answers are usually labels, like as an example, like, is it going to rain tomorrow? Yes or no, which is then converted into numbers and then given to this algorithm. And then once the equation is made, those are the rules that the computer comes up with. And then when you have that equation, what happens is in the background, usually substitute values. And then when those values are substituted, if you remember your month, that's when you get the prediction of whether it's going to rain on the next day. Great. So most of the time, when you're looking at this classical neural network, these are the ones that we use for solving like that problem I've just mentioned before. And they usually have these things called neural network architectures. And that's just a fancy way of saying there's different ways of you give this system data, and then it's transformed in a particular way. For instance, the one that I've mentioned, you can use maybe a classic, maybe logistic regression implemented like using neural networks to solve the problem. And that's more moving into how the old kind of techniques. And there are other ones that are used for maybe processing like images, video, but that one requires you to change your data in a specific way. So that comes into the convolutional neural networks, or CNNs. And then for text data, people used to use things like recurrent neural networks or long short-term memory. And right now, people are using something called transformers to do that. Yeah, I won't go into like a lot of intricacies about how those works, but like since I've just mentioned them, you can please go look into them. But the classic examples of maybe the transformer one is the ChatGPT you use. It uses the whole transformer architecture. So this diagram kind of tells you a bit of what's going on with like the neural network. We're just referencing the example I gave. And here, when you give it data, so when you're giving data to systems like this, the data is usually numeric. You have to find a way to convert everything that you're trying to solve into a numerical form in this container called like maybe a matrix and something called a scalar. So a matrix is just rows and columns of numbers. A scalar is just maybe an array full of numbers, and those represent now your input data, and the things like the true targets are now those values that I've said in the scalar. So your data goes through a series of transformations, and the simplest thing I can say is multiplications and additions. So there's a lot of that happens within the guts of this like systems. And once that occurs, like let me give you a classic example. Like when you're multiplying a number and there's a big signal, or let's say there's something important happening with maybe another number you're multiplying, it's a big number. Like you'll get a big result if both numbers are like big, right? So usually the signal is propagated more when the numbers are big within your matrices and within the matrices. And then once that happens, you have something called what do you call it? Uh, Values, right? So you'll get predictions. And these predictions are now come as these scalars. And what happens is you're able to do element-wise, maybe subtraction or other operations. And then once you have that, like maybe if it's this one, it could be, yeah, let's just keep it at that. I don't want to like overburden you with so many terms. But once we compare what the neural network came up with and our true labels, we get something called a loss score. And once we have that, this is now the signal that we give something called an optimizer, which does something called back propagation. That's like maybe doing, it's like this, the rough example is going through your work when you're doing math problems. And once that happens, the formula is updated. And when the formula is updated, you'll now get maybe a formula or a summarization of, hey, these are the things that influence whether it's going to rain the next day. And if I give values over and over again, I'll be able to predict it. So ultimately, we are trying to create this equation, which people have been saying, like my previous instructors have been saying, like model. So model is now that equation that these machine learning algorithms, like they're saturated with those like values, and then once you have those values, you'll be able to substitute and get a prediction. Great. That is my rough introduction to ML, which is a subsection of artificial intelligence. And that's the crash course. Now I have an exercise for you guys. Let's say I'm trying to build a road, and these values over here, don't mind the equations there. These blue dots are houses, and then the red line is a road, right? So blue for houses, red for road. So my question here is, which you can also type in the chat, is what is the best configuration to put the road? Is it the diagram here? We'll call this diagram 1 or this diagram 2. Please just, if you can respond in the chat, I'd appreciate that, so that I can take the least amount of your time. Oh, there's someone who raised their hand. Please go ahead.
configuration.
Repeat my question. My question was, we have two diagrams here. The blue dots are the houses, and then the red is the road. And then from the two diagrams, which diagram do you think? So the diagram on the configuration 1 and configuration 2, like which one do you think is the best for putting the road? Okay, Bestin Okinda says configuration 1. Does anyone else want to share? Okay. I think we, since I'm going to cover like a lot of stuff, I think we can now move on. So people are saying, at least from the chart here, that the configuration 1 is the best, and I could say that more or less because we are seeing, like, at least even if it's not everyone who's the closest to the road, they are pretty close, like in terms of distance, at least when you're looking at this Cartesian plane. And there is this second diagram over here. So most of the time when you're doing like classic ML or machine learning, we would want a smaller equation like this, because remember when I said like those values for predicting the if it's going to rain the next day, like this X you can substitute it with maybe something like humidity, and this other X you can substitute it maybe with, I don't know, temperature as an example. And then it's easier to explain this than this formula over here. So degree 2 means like you don't have a lot of, what do you call it, coefficients. So these are coefficients, and these are just two coefficients, as you can see over here. And then over here we have like a degree of 10. That means you have like about 10 coefficients over here. So when you're trying to predict stuff, you just add a number here, and then you multiply it. Here you just square it, here you just multiply. But my whole point is it's harder to explain what's going on in this configuration than this configuration. But interestingly, I think with time we have made models, at least with large language models, which look like this. And we are still like trying to figure out what's going on in something as complicated as this. Obviously, this is just an example. The equations that come. A couple of tools that or off-the-shelf models that Google provides in their Google Cloud platform, and also the model Gemini, as well as other related like techniques regarding the large language models, things like the chat GPTs that help now interact with these models and be able to do other things apart from generating text. So that's what's coming already. So I think from the previous like code labs that you may have gone through, or some of the speakers have gone through, it's a good idea to set up your Google Cloud environment so that you're able to get specific credentials to do with like accessing Google services, as well as activating some APIs so that you're able to use some of these examples, or actually run these examples that we have here. So just take advantage of the credits and you can start rock and rolling. So here we are going to cover this couple of tasks over here, which are very popular when it comes to the whole machine learning space. And again, this is just a bit of prose about setting up your account. And then once that's set up, you export JSON, or a file in JSON, which you can now use to basically show your ID when you're calling for services programmatically. So as Dagi said, it's always good to know what your environment, or what environment you're using, or OS you're using here. And here I'm using Ubuntu 22.04, and this is mostly important because of Docker, which helps you now offload some of these tasks that you might have to the guys who will actually deploy it in the cloud. And you have the same environment in your development environment here, which is Colab, and where they're going to run it. Also, the Python version is very important as well to check out. And this is how you run Python, or how to figure out your Python version. So this exclamation mark here means that I am running this command like with, I'm using the Python IDE to run this, as opposed to bash, because if you just run it like without specifying this magic, then what happens is you just run bash. And this here, you're specifically running Python. Great. So here, what I'm doing is trying to find out what Python packages have been installed within my environment. There are a couple from Google Cloud, and like here, you can acknowledge we don't have Africa stocking because it would be part of the list. And part of this example, I'm going to have somewhere where you're going to try and send an SMS. So we just install everything, and this dash key, what it means is it's quiet, so you won't be seeing the dependencies which come. So just to make the output a bit more easier to look into, so that's why I did that. But sometimes it's a good idea to look into what else is being installed. Just for this example, so good on us, we're not using that. And then there is also checking the authors of the packages, as well as maybe some URL where you can find more information, or the homepage. Yeah, this is just more of knowing who is writing these particular packages you're installing, because sometimes guys can do some weird things with these packages, and you end up installing not what is intended. So sometimes it's a good idea to look into this. And so far, I think we are good. FastMCP is for making model context protocol servers, which I'm going to go through at a particular point in time. And again, this is just making like these GPTs, or generative pre-trained transformers, to do other things apart from generating text. And then the ADK framework is for agents. I'll let you know what agents are. And this is still to do with agents. And then finally, there's Africa's talking here. This looks correct. So I think we can move on. Another thing I do most of the time is I aggregate all my inputs into one cell. So this is called a cell. This is where you write your code. And it comes in different flavors. It can be just text or markdown as you are told. And that's I usually run. Like if I wanted to make the next cell, I'd come here, make sure it's highlighted, and then click on escape, and then B, and then it will make another code cell, which is for writing code, right? Then if I click on M, yeah, some shortcuts might not work, but from what I shared in the chat, they'll work in, what do you call it, the Jupyter Notebook. So if you wanted text, you could just say, hey, I want text, so it will come out as text. But again, the shortcuts are they really save you a lot of time. So it might be a good idea to learn some of them. Okay, so this section just looks at the fundamentals of creating data, not creating data, of putting data in a way that is easier for you to run, like this, maybe big data tools like things like Spark, or just to do a lot of data sciencey or machine learning tasks. It's always nice to have data already aggregated and stored away somewhere in a database or an S3 bucket to be able to do like large scale like data science and machine learning. And this prose over here is supposed to talk about like how you can do that with some of these services I mentioned here. And this is another way of now adding citations as well. This is just Markdown. So you can just double click and then you can see how I did it. All right, let's jump into the Cloud Vision API. So this has utilities or off-the-shelf models that Google has made to be able to help you do different tasks. And one is label detection. This is you give this particular model an image, and then it's able to detect like what this image is. Like if you give it a cat, it'll say a cat. This is a cat, so the computer is able to classify something as a cat. Face detection, if you give it an image with human face, it'll be able to detect the face despite the different, what do you call them, races. It's supposed to be able to detect that. And then there's optical character recognition, which is associated with trying to figure out what's going on in text, like in documents, like text, and trying to understand, or the computer is supposed to tell you like maybe a summary of what's going on in the text, and be able to even figure out what's going on with your handwriting as well, to be able to maybe read receipts as well. But first things first, we need to get our GCP credentials like rolling in our environment here. But ahead of time, I have added my credentials like you've been shown before. This is how you safely add credentials in Google Colab. And these are other credentials that I've done for other projects, but the ones that are relevant have been checked out. Also, the JSON that's generated, you can also add it here with a key value pair and be able to access it as well using your, maybe you can call this Vault. All right, so let's jump back there. And also in my environment, when this loads up, you will be able to see in my handy dandy storage place, the GCP credentials are available here, so that in case we are able to, if we need them, they'll be available. All right, so here we'll load up some methods to be able to help us detect something, what's going on in an image. This is an image of a cat with the caption "Wake up human." So if you have access to this notebook, you can be able to see the image. I'm just being a bit more mindful about resources because my computer here is doing a lot of things in the background. So another shortcut that I'm running instead of clicking the play button is Shift and Enter, which is now allowing me to run the code cell. And here we get a correct classification with, I think this is the classification accuracy, which is 0.99. And this is other information about the scientific name of the particular animal, which is in the image, as well as some categorization of its eating habits. It's a carnivore, and other information as well. So now this is the label classification I talked about. Give it an image and the computer is able to say what's going on in the image. So you can also take a step ahead, take a step to now actually fine tune. So fine tune is now associated with adjusting parts of the neural network architecture or the convolutional neural network that was used to make this particular model, to now adapt it to maybe your use case. Maybe it's detecting the cats or dogs problem, for instance. But I think this one is very vast. I think it's using something called the ImageNet dataset, which is data curated for a couple of things that are going on the internet. So I think it will be able to classify a lot of things, but there are some instances where it won't be able to. Another thing is object detection. This is now, apart from saying like this is a cat, it also draws a box around where the cat is. That's important, especially for counting problems. Maybe you're trying to count coins, or you have a system you're trying to make to count coins in a kiosk. So you can use that to actually pinpoint where the coins are, or something a bit more sophisticated. So here we are going to simulate a drone that's just flown through Nairobi, and it has gotten some information about, yeah. So we have, so the drone has gone through Nairobi and taken a couple of images of buildings, and it's supposed to detect the buildings. So this is now running the model through the API, and we're supposed to get an image back, and with a couple of like buildings which have been highlighted, the Times Tower, KICC is over there, and some other ones. So obviously you can find a way to request more services in GCP to be able to fine tune, to now be able to also add more bounding boxes to the buildings. So that's a good start for a drone, right? So yeah, I'm just hiding the output so that it's easier to scroll as well. So now we are moving to natural language processing using the natural language API. So this is just natural language processing is a way of the computer is able to figure out like text. So it's able to figure out like how, like as I'm talking, like what's going on with the text that I'm generating out of my face, or out of my sorry, not my face, out of my larynx. Or so what happens is there are a couple of tasks. So you're trying to figure out what's going on in text. So it's able to figure out what's a noun, what's a verb in whatever it is I'm saying, or maybe even summarize the text if it's like a big block of text, or maybe even identify entities in the text. So now entity recognition comes in. So entity recognition is just simply where you give these models text and they're able to identify particular things in the text, like people's names, if companies, and pretty much like the spectrum is huge, but those are the things that you're able to identify. And then there's another task called sentiment analysis, which is just determining the emotional intent from text. People use this a lot when going through maybe feedback from maybe Google reviews from Google Maps, as an example, for a particular maybe restaurant. And then the syntactic analysis is now that one for breaking down a sentence and figuring out what these parts of the sentence mean, or part of the sentence mean, like maybe there's a verb, maybe there's a noun for particular tasks downstream. Maybe it's fine-tuning a large language model. So we just quickly jump into sentiment analysis. We give it a piece of text here with varying tone. We have one that is praising the Google Natural Language API, and then there's another one for, please give me a minute. Okay, we are back. So we have two pieces of text here. One is more on a positive note, and another one is more of a negative note. So when you give out this input, what happens is, always remember, this is converted into a numerical form, and the computer is able to figure out like what parts of the text are actually tell me that this part is pretty positive. The word love is there. The powerful and easy to use is something as well. And for the other one, there's the word very, and disappointed, and slow, and unhelpful, things like those. And it's often good to, in your evaluation pipeline, to also have evaluations when you're running models like this, to be able to show your work, and in terms of, hey, this model is cool, but how is it making the decision that this text is actually negative, this text is actually positive? It's often good to know that, so that you know how to debug in case of issues, because there's sometimes people can be sarcastic or cynical in a way, and you can never know if this is positive or negative, and that can trip up these models. So in situations like those ones, like, it's always good to know what's going on under the hood, and black box the black box, as people say. So the sentiment analysis score, the sentiment score, is usually a value between 0 and 1, with 0.9 being close to 1. That means it's very positive. And then you have the magnitude there, which measures another aspect of sentiment analysis, which will allow you to go through and figure out what that means. But it also follows the same aspect of scaling. If the value is within this scale, then it's incredibly negative or incredibly positive. Or yes. And then there's a sentiment score for the next piece of text, which is negative 0.8, which means it's negative. And if you get values, and another thing to know is the things that are negative are usually denoted in negative scale, and the more away it is from 0, the more negative it is as well. So you can maybe wrap this around some piece of code, and then you'll be able to solve the sentiment analysis problem. And then there's the one for syntactic analysis. It's just breaking down the sentence to figure out specific parts of the word. So this one, apart from saying, I think this is a determine. So we have the adjective here. Quick is an adjective, and then another adjective is followed, and then, yeah, this is just breaking down the sentence and identifying what these parts of speech are. This is usually comes in handy, especially when you're making very specific models, maybe for figuring out what's going on in text, or just teaching about the grammar in English. So the next one is to do with figuring out entities, like names of people and places. Invalid syntax. So here we have a sentence, and we want to identify what's going on here in the sentence. For instance, Odin is supposed to be maybe a name of a person, or yeah, in like Norse mythology, and it got that right. Another thing is like Old Norse, it's been put as other, and text has been put as a work of art just because of how it follows Old Norse in texts. So this API helps you do the entity recognition, and it's done like a decent job here. So those are the kinds of applications people use for natural language processing. Another one which moves now into speech recognition, and there's something called speech to text. So speech to text is just something like maybe you've used your Google keyboard or your Apple keyboard, and you're able to press like an icon that looks like a microphone, and you're able to, instead of typing, just talk, and your your audio is converted to text. And that's just basically what's happening over here with this particular method we have here. So you give it a URI, and then you're able to, which has audio, and it will be able to convert that into text. So this is an example I found in one of the examples that Google provides. And here is the text that's from the audio, but you can confirm obviously by downloading this and listening to it. And then there is the text to speech, which is just converting now this text into audio. So there's going to be a machine generated voice, and which will now say this actual text. But I have another example which I'm going to run here. And also I want you to pay attention to this particular widget I've just made here that helps me like actually play the audio, because audio obviously is generated, right? But then you'll need to maybe write another piece of code to actually run it. And the cool thing about Jupyter is it has these particular functions that can help you now just take the audio and just be able to listen to it while you're doing your development work.
Hello, this is a demonstration of the Google Cloud Text-to-Speech API.
Yeah, so if you play that, the voice will say exactly the text that's here. And also this text-to-speech system is also available in Africa's Talking as well through the voice product. Now moving right along to the video intelligence API. Here you give it a video and you're able to get a summary of what's going on in the video. This could
Hello, this is a demonstration of the Google Cloud.
Sorry. So if you run this, you're able to maybe analyze video and get summaries of what's going on. This could be useful in maybe factory settings where maybe there's broke within the manufacturing line, and maybe that summary would be important for the line workers to identify before, maybe if it's like a conveyor belt system, like problems arise like downstream, maybe during the packing, as an example. So we have an example video here. I think this one was something going on with like a vehicle that was in transit. So we're expecting to see summaries related to transport as this is going on. So also you can make widgets to play videos. I attempted to make one, but for some reason, I think there's a bug I did not fix. So apart from showing what I showed you before, you can also embed YouTube videos and actually watch them here as well using certain commands. So as I said, something to do with transport, a vehicle and a railroad car. So yeah, the reason why you're seeing all this is because, videos are just a couple of images being put together in a particular way. So it's just reading from frame to frame, and this is what's going on. Great. So we've covered the off-the-shelf APIs to do particular tasks, but now we're switching gears to this model called Gemini. So Gemini can do the same tasks that I've demonstrated before. So the whole point is one model can do all these different tasks. You just need to change maybe the instructions a bit. So here we are just going to do the same task we had before, but now, as you can see, the difference is we are giving it a prompt to maybe guide it to be able to instruct it. This is how I want you to explain what's going on in the image, which is basically the internet meme of the cat, and you get a handy dandy explanation here. And I can just paraphrase this for you. Human rights meme about a orange tabby cat. That's correct. And there's text for wake up human. That's also correct. And you can also instruct the model to give you less text or more text just by changing this prompt. Sentiment analysis can also be done by the Gemini 2.5 Flash or even the new models that have come out, the Gemini 3 Pro. So here we just say perform sentiment analysis on the following text, classify the sentiment as positive, negative, neutral, and please also provide an explanation. So again, here I'm just giving the instructions of how I want the text to be formatted. And also when you're interacting with this model, it's always nice to give it also an example like, hey, this is a negative example, this is a positive example. So if that is run, what you get is just now based on this text over here, it has some negative keywords. Gemini was able to identify the negative keyword and give an explanation as to why that was the case, which is also something to do with explainable AI or XAI. This is one of the ways of just to say roughly of doing it when the model actually articulates the reasoning that it had or that the model had when giving this as a negative score. And I'm going to talk about others as we go through the presentation. So since Gemini is multimodal, what that means, it can take different kinds of inputs and things like text, things like audio, and you can able to give it the audio and it'll be able to transcribe that for you and also do something called diarization, which is just identifying the speakers as well. But here again, sidestep, you can also upload you can make a handy dandy widget here that can help you now upload maybe audio files that you might have, and now you can pass it through this function that can help you now sorry, so that can help you take this maybe audio file, and if there are more people talking, be able to identify the speakers and be able to give you the text from the audio. So the audio file, that was the transcript, and then it attempts to give the identify a couple of speakers as well. So diarization is a very hard task as well, identifying speakers. But again, if you have more audio and people actually identify each other as they're talking, then models like Gemini will be able to identify that and help you with tasks like this. So how can we merge like some of the functionality we've seen before with what we provide in Africa's Talking? We're going to help someone who works in KWS just to give a summary of what's going on with the biodiversity. That means the different like plant, animal, insect, like things that are going on in an image as an example. Yeah, so that's mostly it. So you give this system an image and then it's able to identify if what's going on in the image like is like there's a diverse group of things like in terms of living organisms. Like that's what I was saying, like the insects, the plants, the maybe even animals that it might come across. Yeah, so this can help with maybe the game reserve, like tracking like particular animals like rhinos, like white rhinos, or just rhinos in general, or animals, so that you're able to keep track of what's going on in the game of the reserve, and images are being taken continuously in maybe particular intervals, and maybe systems like this are now assessing the images, and maybe the images are sent to a database. So the descriptions of the images are sent to the database, and maybe even the images sent to maybe something a bit flexible, like a cloud, like what's that thing called again? Where am I forgetting? The object storage or cloud storage. So we have a description here. So this is what we sent to the fellow from KWS. So this is just more pros or more explanations about making widgets on Jupyter. So this is now creating a text boxes where you can put information. So again, I'm just making now a button. Now, if someone clicks this, it'll be able to send SMS. So how it works is like when someone clicks this, it's able to run that function I wrote before that helps you send SMSs, but you need to have like a phone number and actual text that you need to send. So that's what's going on here. I'm just creating more functionalities to be able to create one full widget. And yeah, here it is. You have text boxes and a button there. So if I had the guy's number, I would just add it there. And then I'd put the explanation. Oops, that's a lot of code. I'd put the explanation over here, and then I'd send the message. So these are the kinds of applications that you could make as an example. And then in the next section, we're going to talk about large language models and how to add more functionality to them. So thank you, Ian. So let me just move to VS Code. Let's see, I think I'll just have to share my entire screen for this. So hopefully you guys on the other side can see my screen, and I've made an application here that I'll explain as we go what it does. But if in the description in the notebook, you have a link to actually run this particular interface. And here it is. So this is one of the applications I talked about, where we are giving the GPT, or the large language model, like other functionality to use, like sorry. So here we are giving more tooling to our small language model here. It's about 500 MB and it's running in my computer right now. So yes, you can run these models in your computer now. So we can start by maybe giving it this, then I give you a short description of what's going on. So in my interface here, like I give out this prompt, search for the news for the latest technology trends. And if I click on run, what happens in the background is the large language model has access to the internet through the DuckDuckGo API. And if I give it a prompt like this, it's going to do an internet search and be able to format the articles in this handy dandy format. And you can just look into maybe these links. So there's something to do with Hisense, something called nano LED, and you get a small summary over here. Yeah, so that's one example. Then another example is maybe I want to check how much is in my wallet in my Africa Stalking account. I can also do that. I have 60. And if I wanted to also send an SMS, I'd be able to do that as well. So moving right along, let's now look at the logs of this particular application. So if I come here and close that out, we are able to see something very interesting. When you run this particular application, and this is the interesting part I wanted to put your attention. So before my language model actually does a request, there are specific evaluations I put to the prompt, because the attack surface for these language models is very big, because the input here is text, and text can come in all kinds of configurations. So we need ways of mitigating like very harmful things that people can do in this kind of platforms. So that's where this library comes in. It's called Inspect. You can get it in PyPy. And what it helps me do is evaluate every single prompt ahead of sending it to the language model. And it has like functionality to look into several things. So the first thing is prompt injection. So prompt injection, the simplest way I can say that what that is it's just simply sweet talking the large language model to do maybe something that you'd prefer, as opposed to what it's been programmed to do. So it can be things like maybe creating maybe a chemical bomb or something, and maybe that's not something that you wanted to share, or within your interface, that's not something you wanted to share. So this will flag that, and in the interface, it won't even be able to generate output. And again, the reason why I'm doing that is just because of, again, the wide scope of audiences that could use this, and maybe if I move this to production and if I was giving this as a service, these are the things you need to put into consideration, because if your model gets hacked, it will no longer be doing its particular focus, which I had written over here as a system prompt. So a system prompt is just simply a description of what you want the model to do, and that's like its functionality, and it's going to follow that as its directive, like this is what I'm supposed to be able to do. You can think of it as its constitution. So for the one that I'm going to show you, it's mostly hinged on yeah, so this one is mostly hinged on just being a service that helps you do or to interact with the communication APIs. And here's some of the functionality. Obviously, you can give it more descriptions, but also there's a version that helps you go through receipts and invoices. So this one is able to go, like you give it images, it'll be able to process the images and be able to give you like information that's going on in maybe a receipt. Obviously, you can add more functionality as well. So yeah, it's always important to have these system prompts given to your model so that they be able to do the specific tasks that you have, that you've set them out to do, and at least mitigate the these particular attacks that some people might do. So that's prompt injection. Now, another thing you can put into consideration while doing this is also the toxicity and bias. So bias, you can think of it as the initial assumption that you can have, especially when you're writing these equations. There's that last value away from those x's I showed you initially. That's the initial assumption, like maybe it's going to not rain or maybe it's going to rain, as an example. So these models have inherent bias just because of how they were trained and the information that's exposed to them. So putting that into consideration is important as well, so that you are able to, again, understand what's going on with your model and be able to like tweak it to the best of your ability so that you're able to make really cool products. So yeah, so what happens is there are models, the small models I use, or there are certain APIs I usually run. And what happens is there's a already existing model that you can find in a platform like Hugging Face, especially the model repository kind of part, where now you can call that model and it will be able to, you'll be able to give it text and you'll be able to classify or be able to look at the text and be able to tell you, hey, this is biased because of this and this and this. Yeah, so inherently this inspect library will either use models that it's loaded within the memory of maybe the container or that you've put this to run in, and you can be able to like detect that bias. And then the toxicity is also something to look into, where like there are some particular things you can have conversations with these models, and then they'll be so on your side, which sometimes can be bad. That's why it's always nice to adjust that system prompt. So even when you're using ChatGPT, make sure you just go to your settings and maybe set the instructions that you'd prefer, and also the voice. Maybe you want it to be a scenic, maybe you want it to be very nerdy, whatever you like, just make sure you change those parameters. And then maybe depending on what you put in, like you can get very like results that you mostly care about. So yeah, the toxicity is just something that is also detected like with help of this library and external models to be able to help you identify, man, this is a very toxic statement. And these ones are usually maybe related to very sensitive topics, which I don't want to talk about right now. But again, always make sure you have checks when you are deploying systems like this. So another thing is this explainable AI aspect that I talked about. So this model that I'm using here is a reasoning model. So it's able to articulate the steps that it took to actually run the commands. And here it detected there's a function called get wallet balance, which indeed I can confirm there is. And it was able to run that function and be able to help us get now my balance, which was like 60 bob. So it's always nice to have this model thinking tags so that you're able to, again, decipher what's going on with your model. Because again, there's a lot of back and forth that you can have. And if you don't have this, you might not be able to debug why the model maybe fell on the wayside for certain use cases. Okay, great. Now, I think we can talk about agents. We can just stick to this for now so that I can easily transition into agents. So agents are, you can think of them as tooling for the language model. So what happens is language models, like at least when you use the initial version of ChatGPT in 2022 or maybe later, it was mostly able to just generate text. But with time, when you give these models like other tasks, like maybe it's able to process documents, or maybe it's able to do data analysis for you, or maybe do an internet search like I've shown. Like when you add functionality like that to a large language model, you have made it an agent. So that's the simplest description of an agent, at least my version, that you can have. Obviously, people have other definitions, but